Are you feeling like you're just drowning in a sea of AI buzzwords? Artificial intelligence, machine learning, deep learning. They are absolutely everywhere. But what do they actually mean? Well, today, we're going to untangle all of these terms once and for all. It's a real alphabet soup out there, isn't it? AI, ML, DL, these terms get thrown around all the time, and a lot of people use them interchangeably. But here's the thing, they are definitely not the same thing. So the big question is, what is the real difference, and how do they all fit together? Okay, let's dive right in. I think the absolute best way to get your head around all this is with a super simple analogy, Russian nesting dolls. You know the ones, right? Where one doll fits inside another, which fits inside another. Some of these fields work just like that, getting more and more specific as we go deeper. First up, let's get the big picture. To really build our mental map here, we have to start from the outside with the biggest doll. This is going to give us the foundation for everything else we're about to find inside. So that biggest outermost doll, that's computer science. It's this massive foundational field. It gives us everything from the hardware to the algorithms to the basic theory of computation. Literally everything we're discussing today is a branch growing from this one huge tree.
Now, let's crack open that first doll. Inside we find our first key player, artificial intelligence, or just AI. And this is so important to get right. AI isn't some separate universe, it's a major subfield that lives within computer science. And it's all about the goal of creating intelligent systems.
All right, so we've got our outer layer established. Now it's time to zoom in and really get into the details. What happens when we open up that AI doll? What's the next layer waiting for us inside? And there it is, machine learning. This is such a crucial distinction. Machine learning isn't a rival to AI, it's one of the most powerful ways we have to achieve AI. It's all about creating systems that can learn and get better from data on their own instead of a human having to explicitly program every single rule. So let's just nail this down, because it's the most important point yet. When you hear someone talking about machine learning, they're talking about a specific and very powerful branch of artificial intelligence. Our second doll fits perfectly inside our first. Simple as that. You know what's coming next, don't you? We've got to ask, can we open this doll too? Is there another layer to this thing?
You bet there is. When we open up the machine learning doll, we find deep learning. This is an even more specialized technique. It's a subfield of a subfield. And honestly, this is the engine behind so many of the most incredible AI breakthroughs you hear about in the news, from crazy good image recognition to all these new large language models.
So what makes it deep? Well, it's not some big philosophical thing. As this slide explains, the depth is all about the incredible complexity of its mathematical models. These models have tons of layers, and it's only because we have such powerful computers now that we can actually build and train these incredibly complex structures. And this slide just pulls it all together so well. Look at this hierarchy, right? We start with the big, broad goal, artificial intelligence, creating intelligent systems. A key way to do that is machine learning, where systems learn from data. And then a powerful, super specialized technique inside machine learning is deep learning, using those crazy complex models. See, each layer is just a more specific part of the one before it. Okay, but you might be thinking, hey, wait a minute. Where do other big buzzwords like data science and robotics fit in? Well, that's a great question, because not everything is a doll that fits perfectly inside another. Let's call these guys the related cousins. First up is data science. Now, this is not another doll that fits inside our stack. It's way better to think of this one as an umbrella term. It's a really practical discipline that basically pulls from a bunch of different areas to solve real-world problems using data. This chart shows it perfectly. See how data science pulls from machine learning, but it also leans heavily on good old-fashioned statistics, traditional computer science skills, and something that's absolutely crucial, domain expertise. That just means you actually have to know about the business or the science or whatever field you're applying these techniques to. All right, let's move on to our other cousin, robotics. Now, if data science is all about finding insights in data, robotics is about taking action in the physical world. And in a lot of ways, robotics is seen as the ultimate challenge for AI. And that's because a real robot isn't just one thing. It's this incredible integration of almost everything we've been talking about. I mean, look at this list. It needs computer vision to see, natural language processing to understand, and machine learning to adapt and learn. Robotics is where all this theory gets its hands dirty in the real world.
But hold on, what even is a robot? We all have this sci-fi image in our head of these humanoid machines, right? The reality is much, much broader.
As this slide points out, a robot is really just a machine designed for a specific application. So think less C3PO and think more about your dishwasher. Seriously, it's a machine with sensors and motors designed to perform a specific task. That's a robot.
Okay, we have unpacked all the dolls and we have met the cousins. So let's put all of these pieces together one last time and build that final, clear mental map that you can take with you.
And here it is, your ultimate cheat sheet. Let's just walk through it one more time to lock it in. Artificial intelligence, that's the big overall goal. Machine learning, a key subfield of AI that learns from data to get us to that goal. Deep learning, a super specialized technique inside machine learning that uses those complex models. Then you've got the cousins, data science, the practical umbrella field that uses all these tools to find insights. And finally, robotics, the application field that uses AI to build things that move and act in the real world.
So there you have it, the AI family tree, totally untangled. The next time you hear these buzzwords getting thrown around in a conversation or in an article, you'll have this mental map. You'll know exactly how they all relate. Which leaves us with just one final question to chew on. Now that you can see how all these pieces connect, where do you think the next really big breakthrough is going to come from?